episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, to another episode of our show with another truly fascinating guest who is helping to create a better tomorrow. We are honored today to be joined by Dr. Jane Pinelis, who is the Chief of Testing, Evaluation, and Assessment of Artificial Intelligence and Machine Learning at the Department of Defense Joint Artificial Intelligence Center, or JAIC. Dr. Pinelis has her bachelor's, master's, and a Ph.D. from the University of Michigan in the field of statistics, where she spent time as a research assistant in their Center for Russian and East European Studies, as well as their Institute for Social Research. Prior to her assuming her current role at JAIC, Dr. Pinelis spent 4 years at the Johns Hopkins University Applied Physics Laboratory, where she served in a variety of roles, including as Director of Test and Evaluation of Algorithmic Warfare, where she was an on-site representative of the Undersecretary of Defense for Intelligence, where she oversaw developmental and operational testing of artificial intelligence algorithms, including computer vision, machine translation, facial recognition, natural language processing, and human-machine teaming. She's also served as test science lead for the Institute of Defense Analysis in scientific and analytical roles for the CNA group, as well as a liaison to both the United States Marine Corps and Navy. And just as a little background, JAIC is an organization that's exploring the use of artificial intelligence, network of networks, and AI-enhanced communication for use in actual combat. It's a subdivision of the U.S. Armed Forces, was created back in 2018, and its stated objective is to transform the United States Department of Defense by accelerating the delivery and adoption of AI to achieve mission impact at scale. Dr. Jane Pinelis, thank you for taking time out of your schedule to come join us today.
Thank you so much for having me here. This is really exciting.
Great, thank you for coming. I mean, typically, we like to start things off by handing the floor over to our guests just for a little bit to talk about themselves. If you could take a few minutes to just sort of introduce yourself, a little bit about where you grew up, how you developed this interest in mathematics, statistics, and a little bit of your journey to date in both academia and defense. I think that'd be a great way to start things off.
Sure, thank you. Who doesn't like to talk about themselves, right? So I was born and raised in Moscow in Russia. My family lived there until I was 15. And it's at that point that we immigrated to the United States, to the state of Michigan, Detroit metro area. My dad is a mechanical engineer, and so he had some background in the automotive field. And so we moved because that seemed like a good place for him to work. I finished high school there. It was obviously, it's an interesting time to move when you're 15. But I managed to finish high school there, and I attended University of Michigan, Ann Arbor. I changed my major 8 times in college, still managing to graduate in 4 years. But I've majored in pre-business, astronomy for a little bit, even art history for a short time, but ultimately emerged with a degree in statistics and economics and a minor in math. And my interest in that really was, I think largely thanks to, frankly, the professors I had, that really made me realize that statistics especially is just a tool, right? It's a tool for other applications. And as a result of that, you never really stop learning, which is what really excited me about statistics. And I think there's a famous statistician, I believe it was John Tukey, but I could be mistaken, who said, the best part about statistics is that you get to play in everyone else's backyard. And that's kind of how I look at it. It's a tool that enables you to play in everybody else's backyard and to keep learning about new applications as you go. So I thought that was really exciting. And so I stuck around University of Michigan to keep taking more statistics classes and eventually get my master's and PhD, because I really think when you graduate with just a bachelor degree in statistics, it's one of those sciences, there's just no way that you know enough to really apply it in the real world. My dissertation and the focus of my research was causal inference and observational studies. Which I still think is a really fascinating area. It's matured quite a bit since I've written my thesis, but the idea there was that in a situation where you cannot ethically conduct an experiment, for instance, when you're trying to evaluate the impact of smoking on pregnant women or something like that, right, where you could never conduct an experiment, how do you use observational data that you have on hand or non-experimental data that you have on hand to still connect treatments causally to outcomes? And so, I worked at the Institute for Social Research, as you mentioned, at University of Michigan, which really was, I don't think I realized it at the time, but that was my first introduction into kind of a policy world, because using causal inference for observational studies, you don't necessarily just evaluate medical treatments, even though that's how I started. You can actually evaluate policy effects. And so I spent some time, working with, for instance, No Child Left Behind in Michigan, which is an educational program. And it really provided me a great opportunity to kind of start diversifying the applications of what I'm learning, the applications of statistics and causal inference specifically. And then, towards the end of my PhD, I attended Joint Statistical Meetings, which is a big annual statistics conference. They have a big job fair. And I went into it really open-minded, really not knowing, what I'd get out of it. And I talked to, I think, 14 companies in 3 days, to the point where I was having a hard time kind of keeping straight who's who and who does what. But one place that really stood out to me was CNA, Center for Naval Analysis. It was partially because of the person who interviewed me, David Rodney, who ended up hiring me at CNA, and partially he's just really great at selling it and just a really genuinely nice person to talk to. But it's also, what he was selling, which was the CNA experience. CNA is very unique in that they allow their analysts, and in fact, they encourage their analysts to go to the field. And so you don't necessarily need to just sit in the office. You can go and deploy with an aircraft carrier, or you can go and deploy to Afghanistan, and really just have these firsthand experiences, right? Which really went along with my interest specifically in applying statistics, and went along with the reason I got involved in statistics to begin with, which was to play in everybody else's backyard. Additionally, being an immigrant to this country, there was definitely a streak of kind of patriotism that encouraged me to serve our nation in this way. So, I ended up working at CNA for about 7 years. I started out in analyzing military manpower, which was a good application of my kind of policy analysis skills. But it became kind of evident to me that that's probably not what my career was going to be. And I got very fortunate. CNA offered me a couple of these field opportunities that were really invaluable to me as a researcher and as an analyst. The first one and ended up really shaping my career. And the first one was with ComOpta 4. That's the Navy's Commander of Test and Evaluation Force.
Okay.
And what was happening, this was maybe 2009, 2010. What was happening was the then director of operational test and evaluation, Dr. Michael Gilmore, who is frankly one of the most highly intelligent people I've ever met. He came down really hard on the services, telling them that they didn't bring in enough scientific and specifically statistical rigor to their operational test. So when you test, a new piece of equipment that the military is trying to buy, a tank or a helmet or something else, how do you design that experiment to learn everything that you need to learn to make your decision about the acquisition of that piece of equipment? He was advocating for introducing a lot more science and a lot more proper design of experiments into the testing practices. And he really came down on ComOpta 4 at the time. And this history is documented in DOT&E memos that he wrote at the time. But he came down on them very hard. And there were some reasons, right, why the services weren't necessarily incorporating this much statistical rigor. Some of them had to do with the fact that sometimes the way we think about analysis as scientists is not super compatible with the way that things actually operate, right? There's kind of a reality to it that we sometimes are just removed from. But also, even when we aren't, the services have a hard time accessing the kind of expertise that is needed to really design these experiments and design these trials that way. And so CNA, which usually supported the services and had me as one of their 2 statisticians, said, hey, you should go help. And I still remember this. This was a question of anti-submarine warfare and designing a test around that. And I knew nothing about it. I had been a manpower analyst for years at that point. And I remember the ride down to come up to Fort. It's about a 4-hour drive. I drove with this guy, Roger Poor, who had been at CNA for 30 or 40 years and was an anti-submarine warfare expert. And on that 4-hour drive, we just had to exchange all of the information that we could with each other so that we arrived to come up to 4 knowledgeable enough about each other's fields to give them good advice. And that kind of started my foray into operational testing, which has, ended up shaping everything I do now. So I supported Come Up to 4 for a while, thanks to CNA. And then they gave me another kind of life-changing and career-changing opportunity. And this had to do in 2000, I think, 12 or 13 at that point. Then Secretary of Defense Leon Panetta removed the ban on women in combat. So women previously were prohibited from entering certain occupations in the military at certain kind of levels. And he wanted to remove that ban. And the question was, at least on the behalf of the Marine Corps, will this affect combat effectiveness? Right? That's the most important variable that we care about. Now, as you can imagine, gender integration is an extremely polarizing matter. And there were just so many people that really were either very for it or very against it without having any data to back up those views. And so I went over and started supporting the Marine Corps Operational Test and Evaluation Activity, MACATIA, in their 1.5 year long experiment to see how the integration of women into combat arms would shape their combat effectiveness. And so that was another fantastic field assignment that I'm very grateful to CNA for, that, I was just on the ground with Marines really learning what they do for a living. Having done that, coming back to the office was a little bit tough. So I ended up with another field billet, this time at the Marine Corps Warfighting Lab. But interestingly, instead of putting me into their experimental division, they put me into their wargaming division, which was contrary to, everything I had done to that point. But it was a really, really great learning opportunity for me. CNA really gave me a chance to kind of round my expertise. And then I got an interesting offer to go over to Johns Hopkins Applied Physics Lab. And I spent just about maybe 1.5 years or 2 years there in the National Security Analysis Department, basically working, and I'll touch, I think, on this at the end too, but basically working to bring, again, that same statistical and scientific rigor into some of the analysis that we were doing. And I eventually ended up forming a small team of analysts who were, especially with a good background specifically for more quantitative and very technical analysis. And that team still exists today. There, I got to focus on completely new and really interesting things like nuclear non-proliferation, which was an entirely new field for me. But again, it's just a way to apply kind of what I already knew to a new world. I got to work on their precision medicine initiative. And also we did some things for warfighter health as well that were kind of relevant to everything I've been doing up until that point. I ended up leaving APL to go and lead the test science team at IDA. That opportunity opened up, and this was the team that supports the Director of Operational Test and Evaluation, right? So when that opportunity opened up, what I really wanted to do with that job is bring the service perspective back to DOT&E, because previously when I had worked both with McAtea and ComOpTet 4, I really thought, okay, at the OSD level, the services perspective is missing. There's a disconnect. And the disconnect is preventing the services from implementing DOT&E guidance properly. And so I thought, okay, wouldn't it be great for me to come in and bring in some of that service perspective? And I think I managed to kind of solidify some of those connections a little bit while I was at IDA. And importantly, I managed to lead a team of mostly statisticians, but really test scientists and analysts to try to prepare the department a little bit more for what's coming their way, which was an AI-enabled systems. While I was at IDA, I was having a great time. It's a really, really good organization to work with. My team was really great. But then I got the call back from APL that said, hey, we have an opportunity at Project Maven. And that just, that was just about impossible to turn down. Mm-hmm. When you get an opportunity like that, and it was the same as the opportunity I had at McAtea. You can just tell this is going to be a career-changing move. This is an opportunity to do something so impactful and so new that I couldn't say no to that. I'm very grateful for APL for taking me back and giving me this opportunity. And so I got to work on Project Maven as their test and evaluation lead for I don't know how, maybe about a year and a half. And then when General Shanahan moved over to the JAIC to be the first director of the JAIC, I was one of the folks that he wanted to take with him. And so he offered me the opportunity to come on board. And that brings me to where I am today. I've been at the JAIC about a year. I'm an IPA, so that's an Intergovernmental Personnel Act. So I'm on loan to them from Johns Hopkins. It's an act that kind of enables that seamless moving between some think tanks and the government. And so I'm on loan temporarily from Hopkins to the JAIC. And so here at the JAIC, I lead our test and evaluation division. Our job is kind of twofold. On the one hand, we provide objective, rigorous, and hopefully credible testing for all of our JAIC products. So the JAIC has something like almost 30 product lines, and we provide testing for all of them. And on the other hand, our responsibility is to enable the rest of the department to test AI-enabled systems when they come their way. And so we're working to deliver testing basically as an enabling service for the rest of the department.
Excellent. Excellent. Really fascinating. And, that kind of leads right into the next thing I wanted to ask you about, because, we've been honored to profile, I guess, what you would call some of your customers within the Defense Department, folks like Brett Vaughn the other day at the Navy, Brian Drake at DIA working on AI applications for, the opioid crisis and so forth, several folks from DARPA. Talk a little bit about sort of, where your directives come from, like, you go in the office on a given day, what you decide to focus on. And then also, obviously there's at the JAIC site, there's a list of these mission initiatives, the primary one, of course, being warfighting operations, but there's many fascinating things underneath that in terms, as you were saying, warfighter health and how AI is permeating various aspects of sort of warfighter health, healthcare services, and so forth, taking care of wildfires and threat reduction. Talk about sort of how you organize your day, how, what you decide to work on in a given day, and so forth.
Sure. So you asked kind of about JAIC customers. And the JAIC customers are really, military services and departments, and then DoD components and agencies. And we don't really think of them as customers anymore as much as we think of them as partners. Okay. And the reason I kind of mention that is because the JAIC is, we've got a new boss, we've got a new director who came in just at the end of last year. And he's kind of moving us, which makes sense. He's moving us temporarily into a different phase of the JAIC, which I think the JAIC started out really as a capability delivery organization under General Shanahan. And now we've delivered some capabilities. We've learned some lessons the hard way. And so now we're moving into more of an enabling organization and a service organization, with still some focus on capability delivery, because you really can't, first of all, because the department just has needs and some things need to be delivered, but also because it's really hard to be an enabling organization without having done things yourself and learned the hard way, I think, on many of these aspects. So, so the JAIC has many partners, right, and co-coms, as you mentioned, in DIA, in some cases, certainly in the services as well. But again, these are, I think, partners more so at this point than their customers, as we move towards kind of accelerating the adoption and integration of AI in the DoD, rather than delivering capabilities as our only function. As you mentioned, we do have some really exciting initiatives that we have going. Anything from joint logistics, right, where we can, we've got a model that predicts reasonably well hot engine, or engine hot starts, I should say, that it, basically alerts you when a maintenance action is needed. On a helicopter, to humanitarian assistance and disaster relief. So we delivered several models to help kind of outline the fire perimeter and these were actually used during the wildfires. And we have a lot of warfighting projects as well. Anything, again, from logistics to autonomy in some cases, and warfighter health as well. That's a very exciting initiative for us, where we're hoping, the warfighter health obviously is an extremely high priority, right? And things like injuries, things like readiness, and so there's a tremendous amount of data out there on our warfighters, and it's a matter of, can we sift through it quickly enough and aggregate it in meaningful ways quickly enough to maintain a higher level of readiness across the force. As far as what I decide to focus on every day, that's a hard question. I think, for the JAIC, the focus for this calendar year is really delivering those enabling services and enabling capabilities. So one of the biggest ones is the Joint Common Foundation. That's a cloud enabled platform for development that hopefully will, be connected to data, to a development environment, to a testing environment that others can use, right? That the JAIC can use and others can use. We have a lot of cross-cutting initiatives for the department. Many of them are run through our 3-star level executive steering board. And so as we try to get information from the department about what everyone else is doing, as we try to aggregate that information, as we try to standardize and hopefully make it easier to synchronize and integrate these capabilities. The ESG also plays a really big role. We have responsibilities to the AI-enabled workforce in the department, right? That's one of the biggest pain points, is the workforce. And so we're working on an education initiative as well. And there are many others as well. So our day, and one of the biggest things also I should mention is the acquisition approach to software in general, but especially to AI. We're doing a lot of work on that at the JAIC as well, and my group is involved with all of these efforts. So our days are kind of hectic, but very meaningful and satisfying.
Wonderful, wonderful. There's an interesting term that we actually heard once before, strangely enough, in the world of vacuum cleaners, and that is this concept of edge computing that we were actually, by the Shark Ninja company of all places, talking about sort of this transition from the internet to the cloud, and now this concept of the edge, how we're creating smart homes with more of the stuff is going to be here as opposed to out there. Also, they sort of briefly touched on the concept of neuromorphic computing. obviously nothing confidentially or anything, but can you just talk through some of these cutting edge tools that you're looking at the JAIC?
So, right now, I'm not sure that I can really talk about just how much we're focused on edge computing necessarily. I think our biggest contribution to computing right now is going to be the Joint Common Foundation.
Okay.
As far as our actual capability development, I think we're largely focused on existing sensors, existing equipment, right? And how can we build AI into some of these existing processes and make them more effective, maybe help the human sift through a lot more information and do it better and do it quicker. I don't necessarily think we're at that stage yet.
In addition to your leadership and all your responsibilities in terms of testing and evaluation and assessment, I've seen your name quite a bit in terms of sort of leading the ethics initiatives at the JAIC, and these core principles of responsibility, equitability, traceability, reliability, and governability. Wonderful, but at the same time, you're in the Defense Department. You have to think of sort of grander things than, make sure my vacuum cleaner doesn't do something wrong. You have missiles and aircraft carriers and so forth. Talk a little bit about the ethics programs that you're involved in as well when it comes to AI.
Sure. And just to be very clear, I don't actually lead them, which is probably for the best. We do have a head of ethics policy, Alka Patel, who is a lawyer by training and is much better suited to lead some of these initiatives. But Alka and I do work very closely together because testing is at least partially where the rubber meets the road on ethics, right? There, as you mentioned, there are the 5 AI ethical principles, but how do you operationalize them, and how do you evaluate whether we're acquiring systems that are conducive with to responsible AI? So testing for adherence to these principles is something that my team absolutely is involved in. And in some cases, it's easy-ish, right? So you think of bias, for instance, or traceability. In some cases, those things are easy to define and certainly easy to look through your data, and say, look, this is what this model was trained on, and this is how it operates in its domain. And then here, once you step out of its domain, then we no longer know its performance and things like that. So in some cases, it's easy, and in some cases, it's very difficult. Like when you go beyond kind of software functions and actually evaluate the entire acquisition approach and development approach of the vendor and whether that's compliant with the ethical principles, right? Because it's not just the model that you're evaluating, it's the entire kind of have we acquired a responsible technology? Mm-hmm. And that's a much bigger question, and I think that's much harder, and I'm thankful that there are people who know more about that at the JAIC than I do. It happens to be absolutely an interest and a passion of mine, and so I'm very lucky to be able to work with Alka on it. We are right now at the JAIC finalizing actually a white paper on how we're planning to test for compliance with some of these ethical principles. And again, like I mentioned, there's some low-hanging fruit, but it's definitely a tough and a long-term question. Now, keep in mind that some of this already exists and has existed in policy for a long time, right? Humans are our biggest autonomous agents, and we've been deploying them for a long time. And we've quantified the expectations that we have of them in many cases, and we have certainly outlined the expectations that we have of their tools and equipment in many cases as well. So importantly, I don't think this is a new problem. It has new elements, certainly with introduction of AI, but we're not starting from zero here.
Jan, a couple of years ago, you wrote a very interesting report when you were at the Johns Hopkins Applied Physics Laboratory. It was entitled Quantifying Improbability, where you do an analysis of an analysis that was done by Lloyd's of London, where they did a sort of a cyber attack blackout scenario on the electric grid. and you were, the thrust of the report was that, you have to, while you look at possibilities of stuff happening, you also have to look at the probability of a bad person or a bad actor, whatever you want to call this, being able to do the thing. Can you just talk about this report for a few minutes, because it was really fascinating?
Well, thank you. And you'll notice on that report, I think there's two other authors ahead of my name that did considerably more work on it. So, so I'll just touch on it briefly. But the idea there is, and it's an idea that's fairly frequent in statistics, I guess, is the idea that you should look at the expected value as opposed to the possibility. Or probability of an event, right? And the way we define the expected value in statistics is the probability of event times its gravity, basically times its value. And you look at that together. And so I believe this was in the context of an attack on the electric grid. And we kind of ran a bunch of simulations trying to say, okay, how likely is this really? What would you really have to do to achieve the kind of gravity that people were worried about? And, if I can connect that actually to my work at the JAIC and what we're doing here for a minute. And this stems from many discussions I've had with Dr. Jill Chrisman, who used to be chief scientist at the JAIC and now is at research and engineering. How do we evaluate our systems now, even for their vulnerability, for robustness, right? And for their vulnerabilities to adversarial attacks and to cyber attacks. And what she mentioned that I think is just really true and very important to realize is that, we look at all these examples, right, where people can turn a stop sign into, a speed sign, and all of a sudden an autonomous vehicle breezes through a stop sign and potentially has really bad consequences. But she reminded me that as we look at our system's vulnerability, we have to look at it as a function of how easy is it to commit that kind of a violation? How easy is it to commit that kind of an attack? And in order to commit that kind of an attack on a system, one has to have really good access to the system at hand. And so as we worry about some of these adversarial attacks on our systems, the first things we should worry about is probably not that, as we should worry about, what can a person really do as a function of their access? And if the person is fairly far removed and doesn't have a ton of information on the kind of AI-enabled system that you're running, what could they do? What are the vulnerabilities there? And we should work through those first, and then kind of inch our way towards if the person has full access to the system, if they've downed a drone or something like that. What kind of an attack is feasible then? And frankly, how long it would take to develop such an attack, and then how could we detect and eventually defend ourselves against such an attack?
Really neat, really neat. The topic of AI is hot everywhere now. We've explored the themes in areas like drug discovery processes and food flavorings. We even had a company on that's trying to use AI to develop new flavors of whiskey. Obviously, you have a very large amount of stuff you're focused on at the JAIC. Just interested, when you're not at the JAIC and you're hanging out having dinner or exercising, whatever, any interesting artificial intelligence ideas that, if I wasn't at the Pentagon, that'd be something interesting that I like to pursue on the AI front. And obviously nothing confidential that you're working on.
Absolutely. I think for me, the few really exciting things tend to lie in the health realm. I really think they're just tremendous applications of AI in health. And there have been some attempts at this already, some successful and some really not successful, right? As we've heard, for instance, from the IBM Watson Health specifically, there were some kind of spectacular failures, which, by the way, is usually where discoveries come from, right? And how we learn the best. So I'm really not saying this as a criticism in any way. But I think the health applications, just for me, just given my interests in precision medicine previously, where I worked at Hopkins, that seems to be much more interesting. And there will be an opportunity to do that at the JAIC as well through our warfighter health mission initiative. So I'm not worried about never getting my hands on that. But I think the applications are just tremendous. The idea that you could potentially have a system that can monitor a person, that potentially can diagnose a person, that can diagnose something really early and really make a life-death kind of difference for someone. To me, I think that that's very exciting, and I'm looking forward to eventually participating a little bit more in that line of research. And I'm not talking about that system as a substitute for a doctor necessarily, right? This is just kind of a daily monitoring system that I'm envisioning, and I think. So at some point when we were working the precision medicine initiative at Johns Hopkins, the question came up of what makes a good doctor. What do people value in a medical professional? And there have been plenty of surveys done on this, it turns out. And to my surprise, as a highly rational person that is a statistician, apparently what people value most in doctors tend to be their like bedside manner and compassion, and think, where to me, you know, exactly your performance at your job. Again, statisticians have this very black and white way of thinking about things sometimes. And so, you know, it's hard for me to imagine AI, you know, being able to substitute for something like bedside manner that you get from a doctor, or compassion or something like that. But it is easy for me to imagine AI being able to sift through, you know, thousands of medical articles faster than a doctor, or identifying, you know, a super unique combination of symptoms in a patient that maybe alerts the doctor to take a look at something, or going through a radiology report and you know, pointing out something that a doctor missed. That I can imagine in the not too distant future, and I think that's really exciting.
Excellent. Jane, one other question that we love to ask our guests. Obviously, you've had an amazing career to date in academia, in private industry, in government, in the Defense Department. And we love to ask the question about important mentors, influencers, family members that have helped along the way, that have kept you on this path. And, you know, if it wasn't for them, Dr. Jane Pinelis would be off practicing law or medicine or something totally different. Take a little time, if you would, to shout out, mention anyone that you want to that's been really instrumental as you developed your career in this space.
Thank you. Well, and just to be clear, I think my family would have been quite happy if I had ended up practicing law or medicine, but hopefully they're happy anyway. You know, first and foremost, certainly my parents have always just kind of encouraged hard work, set us up for success here in the US. When I think of people who immigrate to the US with quote unquote nothing, which in a way we kind of did, but in a way we didn't, because having that kind of parental support and focus on education and work ethic, I think is probably the underlying foundation of literally everything that myself and then my brother as well had to do. You know, as I kind of go through my career, probably one of my big mentors at University of Michigan was Ed Rothman, who's still a professor there. And Ed, I took, you know, his class as an undergrad first, and he subsequently ended up advising me on my honors thesis at University of Michigan, and he eventually was on my dissertation committee as well. And this is really somebody who encouraged me to apply statistics to a variety of different fields, and really showed me how to think about things analytically, I think, for the first time. As I kind of progressed in my career, you know, I was very fortunate at CNA to have some really good mentors, starting kind of in my management chain, but even expanding beyond that. One of the biggest influencers probably is Peter Perla, who was the only other statistician at CNA, and actually kind of largely the father of the wargaming discipline as it exists today at CNA. And Peter really, despite being, you know, a very talented statistician, what he really taught me is, again, the way to apply basic operations analysis, I think, and apply that science to to warfighting, to war gaming, to any kind of work that I was doing at CNA. When I worked at McAtea, I worked with the science advisor there, Paul Johnson. And Paul really helped me, I think, identify what today we would call my brand. I don't think we called it that back then. That's a very modern way of calling things. But at the time, I remember when I was finishing up my work on the gender integration study and kind of figuring out what I was going to do next. And I remember talking to Paul and kind of saying, you know, what do you think my value is? What do you think I bring to the table ultimately? What did I do here? And he really ended up kind of shaping a lot of what I do today by saying, I think the most important thing that you bring is kind of scientific rigor, right, as it applies to everything. And so that was really helpful as I kind of started crafting the rest of my professional journey. Once I left CNA, there were a couple of people at the Applied Physics Lab at Johns Hopkins who really shaped, I think, my career today. One was Christine Fox, who's still at the lab, and Christine actually had previously worked at CNA and also at IDA, as it turned out.
Okay.
But Christine really, I think, has helped me always ask the question of, you know, the purpose of what we're doing. And most importantly, she always values the operator. What's the use to the warfighter? So she has really taught me to ask that question well. And then Dean Fisher, who was one of the folks that hired me at APL to begin with, and then also gave me the opportunity to work on Project Maven by calling me back. I mean, Dean's a really big supporter and a big enabler for me. So I'm very grateful to him as well. So, you know, really, I've been very fortunate, I think, to have these folks as mentors, but there are many other people along the way whom I encountered who maybe didn't take an active mentoring role, but certainly I just kind of learned a lot of different skills from different people. And I'm very grateful for the opportunities that were provided to learn from them.
Excellent message. Excellent message. I appreciate that. Jane, I routinely get contacted, and I know I'm going to get contacted after this show by high school students, people in sort of their freshman year of college and so forth. They're gonna be like, "Oh, I want to be Jane Pinelis. what should I study? What types of, what should I major in, minor in?" Now, you mentioned, thank you very much at the beginning, that you went through 8 different areas before you found what your hotspot was. But for people starting off, for my son that's going to be applying to college soon, he wants to be the next Jane Pinelis. Statistics, the fine arts, history. Where do you push people? What should they be looking at if they want to move down this road and this sort of bleeding edge area that you're involved in?
Sure. I think, for me, what I'm really observing at the JAIC and beyond is that really AI requires a diversity of disciplines, right? I routinely work with people who, so Alka, for instance, has a law background as well as an engineering background. Our deputy director at the JAIC, Jacqueline Tame, she's apparently a trained opera singer, I learned recently. And we work with engineers and warfighters and doctors. So I think it's really, the aperture is very wide. Okay. I think the more important thing is to develop an ability to think independently, develop an ability to conduct thorough analysis, not necessarily in a technical way, right, and potentially in a qualitative way, and to develop an ability to kind of hear people that come from different viewpoints and learn from people as you meet them across your journey. That's certainly what I pride myself on, is throughout my career, both educational and then in the workforce, really being able to learn from people surrounding me. And I think that and kind of passion and hard work will pretty much get you where you need to go. I don't think it's any specific discipline.
Thank you for that.
But I love statistics, and if anybody wants to do that, I highly encourage them to do so. I still think it's one of the funnest disciplines.
Outstanding. Jade, it's been a real pleasure having you today, and once again, really appreciate you taking the time out of your schedule to talk with us. For everybody that's going to be watching this episode on the YouTube channel or listening on the podcast, you've been listening to Dr. Jane Pinelis, Chief of Testing, Evaluation, and Assessment of Artificial Intelligence and Machine Learning at the Department of Defense Joint Artificial Intelligence Center, or JAIC. Jane, once again, thank you for taking the time out. Thank you for sharing all your knowledge with us. And as we say, thank you for helping to create a better tomorrow on all fronts. It's been a real honor. And thank you for protecting the country.
Thank you so much, Ira. It's been a pleasure.